Okay, let's take a look at an example of an exponential equation. Now, a minute ago, we derived it, where it comes from. And again, the B is initial, and M is my rate of change. Now, this is constant multiplier or division, depends which way you want to look at it. So we end up with an x up here, so y equals b times m to the x. Now heads up, in our textbook they write it a little different. I think they call us ab to the x. I don't like that form because I prefer our familiar y, b is initial, m as the rate. Y equals mx plus b plus mx, same idea. Okay, so let's assume that I went out and I'm growing some bugs, okay? And bugs. And I initially count on day 0, my first time when I start this, I have 215 bugs. A week or so later, 1 week later, I have 270. 2 weeks, 337, 3 weeks, 421, and 4 weeks, I have 526 bugs, okay? I want to know how many will I have in the future? What is my general equation to this? So I'm not sure what this is. So the first thing I'm going to do is I'm going to ask myself the question, is this a linear system, linear equation, or is it a exponential equation? Now just a little recap. If it's exponential, now because this one's going increasing, it's going to be a curve upwards. If it was linear, I don't know if you can see this. So if it was linear, it'd be y equals mx plus b. So what I'm going to do is I'm going to use my calculator, and I'm going to figure out the difference in all these. So let's see. 270 minus 215. This to this is 55. Okay, 337. Minus 270 equals 67. 421 minus 337 equals 84. Okay, clearly it's not linear. I'm increasing as I go up. Let's just finish the last one. 526 minus 421 equals 105. Okay, my rate of change is not linear, because I added a different amount every time. Okay? Not linear. Well, let's see if it multiplies or divides by a constant number instead. So I'm going to erase this. Now we're going to look at instead is how do I go from here to here? Well, 215 multiplied by x. Okay? Let's hope it's the same. So I'm going to write an equation out here. I'm going to say 215 times x equals 270. X is that rate of change. So solve for x. Let's see, 270 over 215. 270 divided by 215 equals 1.25, let's call it 1.256. Okay, let's do the next one here and see what it is. And that's going to be 270 times x equals 337. That's 124.8. 1.248. This next one here is 1.249. And this last one is, hey, same thing, 1.249. Okay, we have a constant multiplier of about 1.25. So my constant multiplier on this problem is 1.25. So every generation of bugs that I'm growing is 1.25 more than the previous generation. Okay. If we were to graph it, it would do that curve upwards like this over here. So let's go ahead and see what the equation would be. So I know it's not linear, so I cannot use y equals b plus mx, but this time we're going to go ahead and use y equals this one. So it's an exponential equation. B is my initial value. In this case, it's 215. And my rate of change is 1.25. So times 1.25 to the x. Okay. Orders of operations, say I do the exponent first, so I do 1.25 to the x times 215 equals y. Okay. I can also write this a different way. I think this way is a little cleaner than this one. I don't like these dots for multiplication too much personally, but this is equivalent. So my initial value, my rate of change to the x. Okay. Okay, I'm gonna give a couple homework assignments in here. Let's see if we can find some place to write this on the board. Okay, so you'll have to look in the book, but it's roughly section 513, 521, 531. So I want 5.36, 46, 51, and then 86A and D. Okay, this is this week's assignment. 36, 46, 51, then 86, A and D. If you have any questions, please message me.